Alrighty, so 8.4, and this is going to deal with finding zeros of polynomials. Alright, so this first problem, what they want us to learn is how to take the zeros they give us and find the polynomial that they came from. So it's almost like we're working in reverse from when we find solutions. So they want us to find a polynomial of degree 3 with real coefficients that has zeros of -2, 3, and -4. So remember, when they give you the zeros, they're actually giving you the solutions. Because remember, zeros and solutions are the same thing on a polynomial. So what we want to do is start with these three solutions they're giving us and work in reverse to get that polynomial. So the first thing we do is set each of our solutions in the form of x equals -2, x equals 3, and x equals -4. So the first thing we want to do to this is we want to get a 0 on the right side of each equation. So to get a 0 on that right side, I'm just going to add or subtract that number to both sides. So the first one, since I got x equals -2, I'm going to add a +2 to both sides. So that'll give me an x plus 2 equals 0. And then we'll do that with the other two. We'll subtract 3 and get x minus 3 equals 0. And then on the last one, I'll add 4 to both sides and get x plus 4 equals 0. So when you were solving them to get to this point, you had to factor them. So what we got to do is go in reverse from the factoring, and we're going to have to FOIL these together. So since each of these are set to 0, I can now put each of my factors in parentheses and set this whole thing equal to 0. So it's sort of the same thing y'all been doing. We're just going in reverse on this. So now what we got 3 factors set up equal to 0. And the only operation we can do is multiplying. So what I'm going to do is multiply 2 of these at a time. So I'm going to multiply the last 2 together. So I'm going to bring down my x plus 2. Now what I'll do is I'll take that x minus 3 and x plus 4. I'll do them on the side to see what that's going to equal, and then I'll throw it back down into my equation. So the x minus 3, x plus 4, x times x will give us an x squared. X times 4 will give me a 4x. And then we'll distribute the -3. So -3 times x is -3x. And then my -3 times 4 is a -12. And I'm going to do one more thing. I'm going to add my like terms in the middle, because I got the 4x minus the 3x. That'll give us a 1x, and then minus our 12. So I've got that FOILed, so I'm going to bring that back into my equation now. X squared plus x minus 12, and set all that equal to my 0. Now, Carol, I will say this. it didn't matter which two you foiled first. I usually foil these last two first so that I can keep the smaller term in front at this point. But you could have foiled any two of them together first. All right, so now since we foiled that, we got to now foil the big one. So when we foil this, we'll end up with 6 terms because you got 2 things times 3. So you want to distribute that x through these parentheses, and then we'll distribute the 2 through the parentheses. So I'm going to start out with my x. So I got an x times x squared will be an x to the third. The x times the x is going to give me an x squared. The x times the negative 12 is a negative 12x. And then I'm going to distribute my 2. So 2 times x squared is a 2x squared. 2 times x is a 2x. And then finally, the 2 times negative 12 is a negative 24. All this is equal to 0 still. So the only thing we can do to finish this problem is add any like terms we got. So let's see, I can bring down the x third. It has nothing else. The x squared will add to the 2x squared. So that'll give us 3x squared. That negative 12x will add to the positive 2x. So negative 12 and 2 give me a negative 10x. And then let's see, at the end will be negative 24. And all that's equal to 0. So some of these on MathLab, they'll have you put in the whole polynomial. And then some of them, they'll have blanks where the numbers are. And just see if you can put the right numbers in the blanks. So here's the thing about this. They wanted a degree 3 polynomial. And when we're done, if you notice, my highest degree is the 3. So remember, the degree is the highest exponent. So we ended up with a degree 3. And we have our real coefficients. So that's the story of the day for a while. Is we're going to be doing a lot of foiling. So questions on that?
Not how to do it. It's just the bigger picture of what is this? You know, what is this used for? Like,
well, they're just doing this. If you got a lot of solutions, we're just working backwards to find those actual polynomials. So, well, I don't know that you would see this a lot in life. I think it's more just getting you used to the theory about the zeros, you know.
you know,
And keeping you squared on your algebra pretty much. So this one's the same thing. So we're going to find a polynomial. With zeros of 1, 4i, and negative 4i. But I don't mind these problems because it gives y'all a lot of work on this imaginary numbers. Because that's what that 4i is, and that negative 4i. Those are imaginary numbers. I don't know if you remember imaginary numbers, but you get imaginary numbers from taking square roots of negative numbers. So I'll show you the way to get that 4i, negative 4i, is they would have took the square root of a negative 16. But the square root of a negative number we can't do in the real world because 4 times 4 is a positive 16. Negative 4 times negative 4 is a positive 16. So what they do to get the I, they break this into a square root of 16 times the square root of negative 1. So
Mhm.
now we can take the square root of 16. Square root of 16 would be the 4. And we still
Mhm.
can't take the square root of -1, but we replace the square root of -1 with the I. So anytime you see a imaginary number like
Okay.
this, you know they got that number from taking the
Mhm.
square root of a negative number. Okay.
Okay.
Now these aren't bad if you work with the imaginary stuff first. So let's set this up as the x equals 1, x equals 4i, and then x equals a negative 4i. And then remember next, we want zeros on that right side, so we're going to add and subtract to pull them numbers over. So since that's a positive 1, we're going to subtract 1 from both sides. Then get x minus 1 is 0. I'll subtract 4i from the next one, and I get x minus 4i equals 0. And then on that last one, we're going to add 4i to both sides. And get x plus 4i equals 0. So then I'm going to put all these in parentheses and set the whole thing equal to 0. So I'll have my x minus 1, x minus 4i, and x plus 4i all equal to 0. Now I'm going to tell you on these, I would definitely start with those imaginary ones. These are conjugate pairs of each other. One's plus and one's minus, but notice they got everything else the same. When you FOIL conjugate pairs of imaginary numbers, the imaginary stuff will disappear. So on the side here,
Which is a good.
yeah, that's going to be good. So the x minus 4i times the x plus 4i. So do you remember ever foiling these in life?
No.
So I'm going to fold this like I would before. So I got the x times x will be the x squared. X times 4i is a positive 4ix. In the middle, you got a negative 4i times x. So that'll give me a negative 4ix. Now, the tricky part is this last part. I'm going to multiply the negative 4i times a positive 4i. That's going to give me a negative 16i squared.
Gosh.
Oh, watch this though. Look what's happening in the middle here. That positive
Yeah.
4i, negative 4i, hey, those are going to cancel.
Okay.
So you still got your x squared.
Hmm.
Now, you see this I squared at the end of that 16?
Yeah.
That I squared equals -1. So all I'm going to do, anytime you got a negative 16 I squared, it's like a negative 16 times a -1. So that's going to
Mhm.
make that a positive 16. And then what's nice on this, if you punch that on your calculator, that negative 16 I squared, so I got negative 16. The I is down here by the decimal. So you hit the second button and the decimal, it brings up the I. And then when I square that and hit enter, it gives me my positive 16. So now we got our x minus 1 in the front. This turned into an x squared plus 16. And all that's equal to 0. So I will say this imaginary stuff gives you smaller terms that you got to worry about since it cancels those middles out. So that now I just got to pull these two things times those two. So we'll do our x times x and get an x to the third. X times 16 is a 16x. Negative 1 times x squared is a negative x squared. And then negative 1 times 16 is a negative 16, all equal to 0. So I will say this, on this one, I don't have any like terms, but there's probably one thing I would do to that, and that's put it in order of exponents. Go from your highest exponent down to your lowest. So I would make that an x to the third minus the x squared plus my 16x minus 16, all equal to 0. So what MathStack is going to want is just going to be these polynomials we're getting on that side, okay?
Mm-hmm.
And I'll tell you a trick, if you're noticing, the number of zeros they give me is what my highest exponent's going to equal every time. So we've been doing 3 zeros, so our exponents have been ending up as a 3 when we go through this, okay?
Mm-hmm.
All right, so this one I gave you a little bit of refresher on imaginary. Next, we're going to deal with some radicals. So those are fun also. So I'm going to find a polynomial lowest degree. With zeros of square root of 2, negative square root of 2, and 4. So I'm going to be picky about this. I'm going to FOIL them radicals first. So I'm going to put them in order. I want the x equals 4 first. Then I'll do the x equals square root of 2. And x equals a negative square root of 2. All right, so once
So
again,
you're just putting the 4 first just because it makes it easier to
Yeah.
not deal with the radicals?
right, I
Okay.
want to deal with the radicals first, like I did the imaginary numbers a while ago.
Uh-huh.
Then we'll get an answer, then we'll multiply by what we get out of that 4.
Okay.
So we're going to subtract 4 from this one. Subtract the square root of 2 from the second one. And then add square root of 2 to the last one. All righty, then put all these in parentheses equal to 0. So the thing about radicals, when we multiply these going through this FOILing, numbers outside a radical cannot multiply by numbers under a radical. If they're both under, then you can multiply them. If they're both out, you can multiply them, but you cannot multiply outside number by inside number. So on the side, let me FOIL this.
Mm-hmm.
Now, these are conjugate pairs also, just like those imaginary numbers. Everything's the same except for one subtracted and one's added. So when we FOIL conjugate pairs of radicals, the radicals will be gone. So here's our x times x is x squared. X times square root of 2 is a positive square root of 2 times x. But that x cannot be under that radical, okay? Negative square root of 2 times x is a negative square root of 2 times the x. And then let's see what we get at the end. I got a negative times a positive, so that'll give me a negative square root. Now the 2's are under the radicals on both of them, so now I can multiply 2 times 2 and make that a 4. But notice here, Carol, notice that middle. Opposite signs, so that's going to cancel again. So that middle cancels. So we're going to bring down that x squared. And it's going to be minus. So to get my last number, all we got to do is figure out what the square root of that 4 is. And the square root of 4 is 2. Okay, so now we can replace that over here. We got the x minus 4, and then the x squared minus 2, all equal to 0. So I will say this, Carol, on these problems like this, on these problems, although when I foiled these imaginary numbers, they always end up as a plus. When you foil the radicals, they always end up as a negative.
Really?
Mm.
Is that just this particular problem, or that's just always true?
Always true. Anytime you have conjugate pairs over radicals, it'll be x squared minus whatever was under that radical, basically. So I think there'll be a few in here where we sort of hit the imaginary and the radicals going through here. But that's the hardest we'll do on them, is basically foiling them like that. All right, so notice I had 3 zeros, so when I'm done, I'm expecting my highest exponent to be a 3 after we foil this one, okay? So here we go. We got an x times x squared, which will be an x to the 3rd. X times negative 2 is a negative 2x. My negative 4 times x squared is a negative 4x squared. And then my negative 4 times negative 2 is a positive 8. So I guess the only thing I would do to that was maybe put that in order like we did a while ago. So I'm going to put my x to the 3rd first, minus my 4x squared, minus my 2x plus 8, all equal to 0. All right, so this next one's going to be the tricky one.
Oh, now the tricky one.
But just because they're using words you have to remember from, I think it was 8.1 and 8.2. So I'm going to find a polynomial. Of degree, so here's the tricky part. It's a degree 7.
Ooh.
With negative 3, a 0, with multiplicity 3. 0 is a 0 with multiplicity 3. And 3 is a 0 with multiplicity 1. So unfortunately, what they mean by degree 7 is this has 7 solutions. So let's see what we got. We got negative 3 is a 0 with multiplicity 3. So the multiplicity tells you how many times that 0 happens. So since you got a multiplicity 3, you got x equals negative 3 times. Then it says you got 0 is a 0 with multiplicity 3. So that means I got 3 answers that are x equals 0. Now we'll say those x equals 0s are lifesavers to us in a way. And then let's see, my last 0 looks like 3 was a 0 with multiplicity 1. So that means x equals 3 happens 1 time. So now I'm going to get zeros on the right side of all these. So the first 3, we're going to add 3. So all those will give me a x plus 3 equals 0. The zeros I can't do nothing to. I've already got my 0 on the right side. But the last one, I'm going to subtract 3 and get x minus 3 equal to 0. All right. All these single factors right here with the x's, I'm going to put them first because we'll do them like a distribute them at the end. So I'm going to put my 3 x's. And then I guess I'll put all these x plus 3s and x minus 3s. All this equal to 0. So in the beginning, we know what x times the x times the x is. So I'm going to shorten that, those 3 x's in the beginning, x times x times x. I'm going to write that as a x to the 3rd. And then on the side, I'm going to FOIL 2 things at once. I'm going to FOIL the first 2 sets, and then I'll FOIL these last 2 sets. So on the side, I'm going to first do the x plus 3 times x plus 3. So that'll give us an x squared plus 3x plus 3x plus 3 times 3 is 9. So that we get an x squared, and the middle, 3 and 3 give me 6x plus my 9. So I'm going to put that in here for these 2, x squared plus 6x plus 9. Now I'm going to FOIL those last 2, which is the x plus 3, x minus 3. Now those are conjugate pairs, so some of this will cancel on this one, okay? So x times x is an x squared. X times negative 3 is a negative 3x. 3 times x is a positive 3x. And then 3 times negative 3 is a negative 9. So if you notice, the x's in the middle cancel. So that one ends up as an x squared minus 9. So you remember a while ago, the imaginary things, when I FOILed them, gave me pluses. Everything else will give you a negative on that, okay? Just like the radicals. All right, so we get to put that right here, x squared minus 9. All right, Carol, so what I want to do now is bring down that x to the 3rd again. And I'm going to FOIL that right side to see what goes into these parentheses. All righty, so let me find somewhere. I'm going to FOIL that on the side. Now, when I FOIL it, I'm probably going to put the x squared minus 9 first, and then the x squared plus 6x plus 9. It don't matter which way you go, but to me, they're easier if you got the smaller stuff up front.
Okay.
All right, so I'm going to FOIL this through. X squared times x squared is an x4. Let me bring my camera down a little bit so we can see all this. X squared times 6x is a 6x to the third. So I'm just adding exponents on the variables. X squared times 9 is 9x squared. Then I got a negative 9 times x squared is a negative 9x squared. Negative 9 times 6x is a negative 54x. And then the negative 9 times 9 is a negative 81. So it looks like to shorten that, the 9x and the negative 9x squareds will cancel. So I end up with my x to the fourth plus 6x to the third minus 54x minus 81. So we can now put that back into our equation over here. So I got an x to the 4 plus a 6x to the third minus a 54x minus 81. So you'll be happy now. All the FOILing's done. All we got to do is distribute this x to the third times all these.
That's all?
And all we're doing is adding 3 to all these exponents. So the x3 times the x4, and then together gives me my x to the 7. So now I'd probably be pretty happy because when we started this, they said find a degree 7 polynomial, and there's my 7. Now the x3 times 6x to the third is a positive 6x to the 6th. Minus x3 times the 54x is the 54x to the 4th. And then x to the third times the 81 is a negative 81x to the third, all equal to my 0. So on that one, they was just looking for this big polynomial here.
And it's already in order.
And it's, yeah, this one ended up being in order when we was coming through it. So that was good. So really, if you notice, the zeros are not bad because all those get multiplied in the front and we just distribute them. All these other zeros are the ones we're having to FOIL and try to get rid of, okay? All righty, so
it's confusing to call, it's confusing to call a solution 0 using the word 0 and not meaning the numeral 0.
You know why they do that,
I don't know how long it took me to figure that out.
The reason they're doing that, because when these things are crossing the x-axis, those are all my solutions. But on that x-axis, what's the y value? The y value is 0 on those x-axis.
Numeral 0.
Because remember, my 0, my y's go up positive and down negative. But right on that x-axis, the y values are all 0. So that's why they call them zeros technically. And then we're also setting all the equations equal to 0 when we're solving them.
All right, so you know where they cross?
Yeah. So all those answers on that, I would know that's where if I had to graph that, I would know that's where they're crossing that x-axis at if them 2s and 3s and all them numbers they're giving us. Although it'd be tricky to figure out where them radicals are on that. You'd have to estimate them out as decimals probably. All right, so here's some little properties about these zeros. So the first one, radical zeros come in conjugate pairs. Whoops, let me pull my screen back up again. Alrighty. So radical zeros come in conjugate pairs. What that means, if square root of 2 is a 0, then negative square root of 2 is a 0. If, oh, let me find another one here. If 2 minus square root of 7 is a 0, then 2 plus square root of 7 is a 0. So notice, on the first one, square root of 2 automatically has a negative square root of 2 as a 0 also.
Mm-hmm.
If you have 2 minus the square root of 7, then you'll have 2 plus square root of 7 as a 0. So the only signs that changes on those radicals, okay? That 2 stays the same. These would have been answers like when you was doing the quadratic formula. Remember how you had that plus and minus in front of that radical? That's how they're getting the 2 different answers, okay? Alrighty, so we're not going to get deep into these. Second one, imaginary zeros come in conjugate pairs. So what that means, if 9i is a 0, then negative 9i is a 0. And then these can also have numbers in the front. You can have something like 3 minus 4i. So if 3 minus 4i is a 0, then 3 plus 4i is a 0. So basically, the radicals and the imaginary numbers always come in conjugate pairs when they're zeros.
Okay.
So this would be one of your easier problems. So suppose a degree 4 polynomial has zeros of negative 5, square root of 3, and 8/5. What is the other zero? Because remember, degree 4 will have 4 zeros. They're giving me 3 of them, so can you guess the last one?
Negative square root of 3.
Damn, and we're done. You gotta love that one, right? So
Yeah.
they're just wanting y'all to get used to these being in conjugate pairs, okay? So let me see if I can put enough on you. So same thing. This is a degree 4 again. So this one has zeros of negative I and 2 minus the square root of 7. What are the other zeros? So if you notice, this one only gave me 2 zeros. They gave me that negative I and then 2 minus square root of 7. So if I got a negative I, then that means I need a positive I. There you go. And if I got a 2 minus square root of 7, my other one would be
2 plus
2
square root of 7.
plus square root of 7. All right, but you only get a couple mild ones, okay?
Let me finish copying the negative I
Okay, so
and
let me pull that
2
up.
minus square root of 7. Okay.
All righty, so here we go. Find a polynomial So anytime they say find a polynomial, you know we're probably going to do a little foiling. So find a polynomial of lowest degree. So they're not telling us the degree because they don't want us to really know how many answers that we're going to use. So they playing with our head on this one. So lowest degree with zeros of negative 3i and a 5. Now, from what they're giving me, I know x will equal to negative 3i. I know I'll have x equals 5. But what's the missing zero they didn't give me that I need?
Positive 3i.
Bam, that's it. And then the 5 I don't worry about because it don't have a conjugate pair. So the only things I got to worry about conjugates are on those imaginaries and on the radicals. All right, so I'm probably going to put my 5 first after I subtract everything and get them moved over. So the first one, I'm going to add my 3i. So x plus 3i is 0. Second one, I'll subtract 3i. And then subtract my 5. So I want to FOIL the conjugate stuff first. So I'm going to put my x minus 5 first. Then my x plus 3i, x minus 3i, all equal to my 0. So I'm going to show you this trick now that we can do to these. Anytime you got conjugate pairs, we can shortcut by multiplying the first two together. So x times x is an x squared. And then multiply the last two together. 3i times negative 3i is a negative 9i squared. So this is anytime you got conjugate pairs, you can FOIL the first two and then the last two. Because this middle stuff always cancels, so we don't have to worry about FOILing that every time. But if you remember, I squared equaled something. So remember, I squared, and I squared equals negative 1.
Squared.
Mm-hmm.
Okay.
So that's going to turn that negative 9i squared.
So that'll be.
And you got what, x squared plus 9 on that, okay? So now I'm going to put that in here. I got my x minus 5. And then my x squared plus 9, all equal to my 0. I tell you, I don't mind these imaginary things because it gives you less things to FOIL over here because you don't never get those middle terms on them. All right, so to finish this up, we got an x times x squared, which is x to the third. X times 9 would be a 9x. Negative 5 times x squared is a negative 5x squared. Negative 5 times 9 is a negative 45, all equal to 0. So I guess the only thing I would do to that would maybe rearrange it. So I get my x third minus the 5x
Mm-hmm.
squared. What's next to plus 9 minus the 45, all equal to 0. So that's why they didn't tell you the degree you're going to end up with, because they didn't want to give you the other imaginary 0. But they want y'all to know that from now on, if they give you an imaginary, you automatically got to count that other one.
Mm-hmm. Yeah, I guess I don't understand what they mean. Find a polynomial of lowest degree. What do they mean by that? Of
Well,
lowest degree.
the degree is the highest exponent.
Uh-huh.
So when they're saying lowest degree, they're not telling us, hey, we want you to find a degree 3 polynomial, because they don't want to give it away that the negative 3i always has a positive 3i 0 also. So, because they'd have said, well, if we'd have put a 3 here, then y'all would have known automatically to make the positive 3i one of the zeros. So they're just trying to be a little tricky on that.
Okay.
They're not giving you too much to see if you can come and see if you remembered to put in that other 0 like you did, okay?
Mm-hmm.
All right, so here's where this is sort of heading to. For the following polynomial, one 0 is given. Find the other zeros. So now we're going to start out with the polynomial and find our zeros. So we're given p of x equals x to the 4th plus 16x squared minus 225. And they're telling me 5i is a 0. So hopefully you picked up on my synthetic division the other day, because that's how I'm going to solve these.
Oh my God. I did watch it.
Well, you'll get to see what I'm going to do here.
Okay.
So since they told me 5i is a 0, I'm going to use 5i as my c when I do my synthetic division. Now,
Oh gosh.
synthetic division, you got to write out all your coefficients. But notice, I'm missing placeholders here, so I don't have an x3 term, so I'm going to put a 0 for it. I don't have an x term in between here, so I'm going to put a 0 for it. So I got a 1 for the x4, a 0 for the x3, 16 for the x squared term, 0 for the x term, and negative 225 is my constant term. So every placeholder has to have a number for it, okay?
Okay.
And then I drew the box, and I always squared off the last section of my box, because that's going to be my remainder. But check this out. Since they told me 5i is a 0, when I'm done, that remainder better be 0, okay? Because that's the property of a 0, is that its remainder is 0 when you do the synthetic division. All right, so what we'll do, we'll run this 0 through synthetic division, and this will give me a quotient here of the new polynomial. I'll then use that new polynomial to get my second 0. Once I've got two zeros and I can get this down to an x squared, I can use the quadratic formula. And I just use it for standard. Hey, but
Was that
but the
Is
quadratic,
that
but at this point, we're hoping y'all are using the quadratic formula on your calculator program we gave you, so you can just zip it in and be done.
I did get, I've got the 83, but I did get it on there.
Okay, that'll work. All right, so let's knock this one out. We're going to bring that 1 straight down into the box. So the first number always goes straight down into the box. Now we want to get to the next column, so we multiply that 1 in the box times the 5i. So 1 times 5i is going to
5i.
give you 5i. Then you would add 0 plus 5i. So that's going to give me a 5i.
Mhm.
So now 5i times 5i on the side, that would be 25i squared, right? But what's that I squared equal?
Mhm.
So that's going to be a negative
Negative
1.
1.
So that's going to turn that 25 into a negative 25. All right, 16 and negative 25 will give me a negative 9. Now I'll do negative 9 times 5i is a negative 45i. Let's see, 0 and negative 45i is a negative 45i. So I wonder what that 5i times negative 45i is. And look at that, that gives me a positive 225. So negative 225, positive 225 gave me my remainder of 0. But we knew that because they told me 5i was a 0. All right, so we got to keep doing synthetic division until we can get this down to 3 numbers under the box. At the moment, I got 4 numbers under that box. So you're going to take these 4 numbers, and that's going to be the next coefficient that we use. So I'm going to bring down to 1, 5i, negative 9, negative 45i. So, Carol, I'm a little lost. I don't know what to try for my next 0. So let me prod you.
Do you do the negative?
Oh, there
Do
you
you
go,
do the
negative.
negative 5i?
Bam, there you go. Because we know those always come in conjugate pairs. So let's knock out the negative 5i.
Uh-huh.
So bring that 1.
Might as well.
So you're getting a little bit of this. So bring that 1 down. Now watch this. 1 times negative 5i is a negative 5i. Oh, but look at that. 5i minus 5i gives me a 0. Well, 0 times that negative 5i, that's 0. Negative 9 plus 0 is negative 9. And then negative 9 times negative 5i is a positive 45i. When you add that, you get a 0. So the zeros, so far we found negative 5i. We don't have to list the 5i because they gave that one to us, okay? So you got 3 numbers down here. With these 3 numbers, I can now use the quad formula. So you said you got the quad on your calculator now?
Yes, but my calculator's on the other side of the room. I gotta go get it.
Okay, well, I'll
Oh
put it
no,
on
it's right
mine.
here.
Okay.
Okay.
So punch in that 10 negative 9, see what we get.
Three and negative 3.
That's it.
Wow.
So that my 3 zeros would be the negative 5i, the 3, and the negative 3. So we had a degree 4 on this one when we started. That was the x to the 4th. So when we done, we needed 4 zeros. They gave me the 5i.
Mhm.
We found the other 3. So I'll tell you what, I got a couple more problems I'd like to show you. Can you hang out another about 20 minutes and that'll save you from having to worry about this on Friday?
Yeah.
Okay. Because I've only got a couple more things I need to show you in this lesson. It's one of the longer ones.
Uh-huh.
So the next one I'm sort of going to work out while I explain it. So they're giving me a polynomial, P of X equals, oh, let me see what's going on. It's going to equal 13 x to the 6th plus 18 x to the 3rd minus 8x squared plus 2x plus 2. They want me to list all possible rational zeros. So what are any numbers that could possibly be zeros of this function? So here's what we do. This first number, the 13, I'm going to call my Q, and the last number, the 2, I'm going to call the P. I guess this is where they get that P's and Q's stuff from math. So all possible rational zeros are going to be plus or minus factors of P divided by all factors of Q. So we find all factors of the last number and divide by all factors of the first number to have all the possible zeros. They might not be zeros, but they could possibly be zeros. These would be the only numbers I would check doing synthetic division, okay? That way you wouldn't have to check an infinite number of numbers. So let's find the factors of P. Well, that's P equals 2. So the factors are going to be 1 and 2. Q is the first number, 13. So factors of 13 are going to be 1 and 13. So at least I had a small amount of factors for my numbers. Okay, if my numbers were like 8, there's be a lot of ways I can get an 8 and so on. So we come over here, plus or minus. I'm going to start with the 1 first. I'm going to take that 1 and divide by this 1 on the bottom. Well, 1 divided by 1 gives me a 1. Then I'm going to take that 1 and divide by the 13. That one don't reduce, so then I'm done. So far I've got plus or minus 1 could be a 0. Plus or minus 1/13 could be a 0. Now, I've used the 1 on top. Now I've got to use the 2 on top. So I get a plus or minus 2 over the first Q, which is 1. Well, 2 over 1, I can make that a 2. And then I take that plus or minus 2 and divide by the second Q, which is a 13. So I'm done. So 2, 4. So these would be the 8 possible zeros that you would get from that polynomial, okay? So I got a funner one if you want to do one more of those. So all the factors of the last number divided by all the factors of that first number, okay?
Okay, that's how you find.
That's how I'm finding. So see, I took both these factors of the 2. I started with the 1. I divided 1 by the 1. And then I divided 1 by that 13 to get both of those. Then I took the 2, the second factor on the P, and I divided it by the 1. And then I divided it by the 13. So every factor of P will divide by every factor of that Q. So I got a bigger one here. P of x is going to equal 10x to the third minus 38 x squared plus 42x minus 21. Now, I'll tell you, I use my graphing on these sometimes to find zeros instead of doing all this guesswork. But remember, here's my Q and my P. So P is the last number, which is 21. And you don't even have to worry about the sign because we do the plus and minus to all of them anyway.
Mm-hmm.
So factors of 21 would be 1, 3, 7, and 21. Then I'll take the factors of the first number, which is 10. And the factors of 10 are 1, 2, 5, and 10. If you notice, this one's going to be a little bit more tedious than my last one. I've got to take every one of these numbers for P and divide by all 4 of these numbers for Q. So I get a plus or minus P's over Q's, okay? So the first one, I'm going to take that 1 on top. Divide by 1. Well, 1 divided by 1 is 1. Then I'll do plus or minus 1 divided by the next Q, which is 2. So that's already simplified, can't do nothing to it. Then I'll take that 1 divided by the 5. That one's simplified, can't do nothing else. And then I'll take that 1 divided by the 10. So I got my first factor of P done. Now I take the next one. So I've done the 1. So now I'm going to do the 3. So 3 divided by 1 is going to be plus or minus 3. 3 divided by 2, cannot simplify. What's next? 3 divided by 5. And then finally 3 divided by the 10. All right, so we've taken care of the 3. So next we would do the 7. So that'd give me what, a plus or minus 7. This ain't bad. This is just time consuming maybe. What's next? 7 divided by 2. 7 divided by the 5. 7 divided by the 10. And then that takes care of the 7. So then finally is the 21. So that'll give me a 21. Then I'll do plus or minus 21 over 2. Plus or minus 21 over 5. And then plus or minus 21 over 10. And none of those simplify. So if I was going to look for zeros on this polynomial and they didn't give me any zeros at all, it would be one of these numbers that I would start with, okay? I would probably start with these whole numbers first and then probably start checking those ones.
Mm-hmm.
But I'm about to do an example where they sort of don't give you no zeros and we got to find them, and I'm going to show you how to do that on that calculator, okay? Because it's a little bit quicker. So the last problem I do, and these are good ones. I'm going to find all zeros of the polynomial. And then I'm going to factor into linear factors. Then factor into linear factors. And all they mean by that is put them in parentheses. So,
Okay.
so let me see what I got here. I got a f of x do this in here. All right, so I got a x to the third minus 91x plus 90. Now remember, I'm going to add a 0 at least for that x squared term when I'm doing my synthetic division. So let's write out our numbers. We got a 1 for the x3, a 0 because there's no x squared term, negative 91, and then a 90. Now this is a degree 3, so when we're done, we should get 3 zeros. So we need to at least find one of them, and then what's left, we'll use our quadratic formula. So what I do to these, I'm going to graph it and see where this is crossing over that x-axis at. So I'm going to go to y equals, and I'm going to do my x to the third. Oh, what was that? Minus 91x plus 90. So I've got my polynomial in there. So now I'm going to try to graph that and see if I can tell where it's crossing over that x-axis. Now, if you see, I got one right here. It looks like about a 2. But if I go to the table, let me find out in that number actually is that a 0 right there? So it looks like it's crossing at the x value of a 1, okay? So let me go back my graph. I guess that's crossing at 1, yeah. But I can tell when I go to the table, okay? Now, I could have used this one way over here, or I could have even used the one that was way on the left side. But yeah, I just pop that in. So since that crossed at 1, my first 0 is going to be a 1 that I check. Now, if I'm right, I better get a 0 for my remainder, okay? All righty, so here I go. I'm going to bring my 1 down. 1 times 1 is 1. Put that under the 0. 0 plus 1 is 1. Bring that down in the box. 1 times 1 is 1. Negative 91 plus 1 is a negative 90. And then negative 90 times 1 is negative 90. So I got a 0 remainder. So I know for sure my first 0 is a 1. Okay? Now, I got 3 numbers here. Since I got 3 numbers, I can now use the quad. See, it's 3 numbers. A will be 1, B will be 1, C will be negative 90. So let's go to program quad to knock this out. So we had a 1, 1, what I say, negative 90. So if you do that, you get x equals 9, x equals negative 10, which are my other 2 zeros, 9 and negative 10. And I'd be happy with that because 9 and 10 and 1 are all factors of that 90, okay? It's got to be a factor of that 90 if it's going to be a 0 for this polynomial. All right, then here's the part when they talk about the linear factors. That'll be f of x equals, and we had 3 zeros, so we'll have 3 factors. Now, here's the thing. If you remember, these factors always had opposite signs than those zeros, right? If x equaled 1, then the factor would have been an x minus 1. If x equals 9, then the factor would be x minus 9. And if the factor was a 10, I mean, the solution was a negative 10, then the factor would be x plus 10. So all they really want you to do is put them into the parentheses as factors instead of as the zeros or the solutions.
Okay. I guess I followed everything except way up there when you were getting the C for this
Uh-huh.
synthetic
Oh,
division.
yeah. Now,
I just had to take it by faith.
well, so I know that the zeros I would check have to be factors of that 90, but
Mhm.
girl, there's a lot of factors of 90. That could be 1, 2, 5s, 10s, all kinds of numbers, right? So what I did, I graphed it. If you can graph these, so I put in my x3 minus my 91x plus 90. Because if you can graph them and look and see where they're crossing the x-axis, that'll give you numbers that you know you can track. That should give you zero remainders, okay? So we put that into there, and I went to my graph. And then my graph is on the 10 by 10, so it's hard to see the whole graph. It's just putting on parts of it.
Mm-hmm.
So there's three numbers I would have looked at. I would have seen where that was crossing over right there, because that's crossing the x-axis. In the middle here where I got my pen, that was
Mm-hmm.
crossing the x-axis at 1, so that's why I tried the 1. Or I could have tried this one over here at the 9, because guess what? My other two zeros were the 9, and then this one must be what? Negative 10, right? So any three of these numbers. Now, if it's hard to tell what the
Mm-hmm.
number is, I
Mm-hmm.
went to the table by hitting second graph. You're looking for numbers that have a y value of 0.
Mm-hmm.
So there's that one at 1. If you come over here to this negative 10 that we've seen, it's got a y value of 0. And then my other one was over here at the right side. So it couldn't have been 8, it was at 9.
Mm.
So all three of these numbers we came up with were zeros on that graph because they had y values of 0. So you could have started with any one of the three, or hell, you could have just looked at the graph and got all three of them answers, couldn't you? When you really can't,
Yeah.
now, but you can't do that every time because remember, some of these zeros might be imaginary or radical, so they won't show up as nice numbers like that. But at least if you can find one, you can get this started so that you can knock it down. Quad formula will always find those radical ones or those imaginary ones, okay? But yeah, by hand, you can't find those. You got to use the quad to get those. And then down here on the linear factors, you see what I did? I just took all these zeros and changed their signs, like almost like when we were solving them earlier on problem 1. I started out with x equals 1 and then subtracted
Mm-hmm.
1. So these are the linear factors they're talking about.
Is there any point in I have not in several weeks been even going to the book. I just watch your videos.
Oh, you're good then.
Is
The book, they're similar, but sometimes they might do stuff a long method.
Yeah, that's what I figured out.
Uh-huh.
I mean,
Um,
square things when you were doing the um oh, what is it? The vertex formula? And they
uh-huh.
were, oh, complete the square. And I'm like, what?
Oh no, I don't do that, girl. That's too much work. You ain't got to do that
Yeah.
with those. No, they get a little carried away sometimes. So
Okay.
what I do then for this 9 o'clock class, since I got through this lecture, Friday I'll use it for like a catch-up stuff. So if there's anything from say, because 8.1 and 8.2 I really couldn't lecture a lot because of the sickness. So I did send videos on those. But if you got questions on anything in chapter 8 so far, I use that time Friday to go over all that.
Okay.
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 So keep that same link if you ever want to join me at 9 o'clock. Um, I'm going to start trying to do these lectures in school on Mondays and Wednesdays in the class. So You can jump on those too, okay? It'll be the same way, except I'll be
Okay.
writing on
Oh,
the
do
board.
you,
Say again.
so you're recording it in the classroom Monday, Wednesday usually?
Yeah, I can record like I'm doing now. I just haven't had good internet at the school to
Oh,
do my Zoom lives. But yeah, once they get my internet
yeah.
fixed, I'll be able to show my board while I'm writing on the board instead of this paper pad that I'm using. It'll be
Wow.
about the same. That way
Well,
y'all
this
can
is
have,
great. I'm telling you, you're helping an old girl remember things. I am 61 years old, and
hey,
I
get
did
there.
homeschool my kids, so I've seen,
Uh-huh.
them go through math. So it's not completely new, but you're really helping me the way you explain things.
Hmm.